How are you, every student? How are you today? This is lecture number 10 in our course Elementary Survey Sampling. This is for third year English section Benha University 2020. This is an important lecture, and this is maybe the last lecture in online courses. And I want from every student to study this lecture and the important definition in this lecture very closely. Chapter 7, Systematic Sampling. This is the third types in sampling after simple random sampling, stratified random sampling, chapter 4, simple random sampling, chapter 5, stratified random sampling, chapter 5, systematic sampling in chapter 7. This is an important chapter in our course related to systematic sampling. In this chapter we will see what is the meaning of systematic sampling, what is the definition of systematic sampling, how we can draw a systematic sampling, and the important advantage related to systematic sampling. This is maybe the last lecture in online course for the third year statistic English section Benha University 2020 in the first semester. Section 7.1, an introduction about systematic sampling. As we have seen in chapter 4 and chapter 5, both simple random sample and stratified random sampling require very detailed work in the sample selection process. Sampling units on an adequate frame must be unburdened or otherwise identified, so that a randomization device such as a random number table can be used to select specific units from the sample. Random number read to simple random sample. A sample survey design that is widely used primarily because it simplifies the sample selection process is called systematic sampling. The basic idea of systematic sampling is as follows. Suppose a sample of n names is to be selected from a long list. A sample way to make this selection is to choose an appropriate interval and to select names at equal intervals along the list. Thus, every tentile name might be selected. For example, if the starting point for this regular selection process is random, the result is systematic sampling. There is a systematic process for choosing the elementary units. Definition 7.1, a sample obtained by randomly selecting one element from the first k element in the frame, and every kth element thereafter is called a 1 in k systematic sample with a random start. As in previous chapters, we present a method for estimating a population mean, total, and proportion. We also discuss appropriate bound on the boundary of estimation and sample size requirement. Systematic sampling provides a useful alternative to simple random sample for the following reason. This is the main advantage, the main goal, the main items, the main aims about the systematic sampling. Number one, it is very important to know by each student very closely. Systematic sampling is easier to perform in the field and hence is less subject to selection errors by field workers than are either simple random sample or stratified random samples, especially if a good frame is not available. Number two, systematic sampling can provide greater information. Systematic sampling can provide greater information per unit cost than simple random sample can for populations with certain patterns in an arrangement of elements. This is the main true advantage in systematic sampling rather than simple random sample and stratified random sample. So that it's very important to know, and every student must study these two main important advantages or important advantage or aims or objective about systematic sampling and the definition of systematic sampling. Now you can go to section 7.2, how to draw a systematic sample. What is the process to select the units, the terms in systematic sampling? Although simple random sampling and the systematic sampling both provide useful alternatives to one another. Give me your attention. Although simple random sampling and systematic sampling both provide useful alternatives to one another, the method of selecting the sample data are different. A simple random sample from a population is selected by using a table of random numbers or random number generating using a computer, as noted in section 4.2 in simple random sample chapter, in chapter 4. In contrast, various methods are possible in systematic sampling. There are several ways, several methods in systematic sampling. The investigator can select a 1 in 3, a 1 in 4, or in general a 1 in k systematic sample. For example, a medical investigator interested in obtaining information about the average of number of times 15,000 specialists predicted a certain drug in the previous year. N equal 15,000 in the capital, the grand N capital equal 15,000. To obtain a simple random sample of a small n equal 106,600 specialists, we use the methods in section 4.2 and refer to a table of random number. However, this procedures requires a great deal of work. Alternatively, we could select one name specialist in random from the first k equal 9 names appearing on the list, and then select every 9th name thereafter until a sample of size 1,600 is selected. This sample is called a 1 in 9 systematic sampling. Again, we could select the one name specialist at random from the first k equal 9 names appearing on the list, and then select every 9th name thereafter until a sample of size 1,600 is selected. This sample is called a 1 in 9 systematic sampling. Now, section 7.3, estimation of population mean and total. As we stated previously, in simple random sampling and systematic random sampling, estimation of population parameter mean and total. Now, we will also calculate population mean and total under systematic sampling. As we have repeatedly started in the simple random sample and stratified random sample, the objective of most sample survey is to estimate one or more population parameters. We can estimate a population mean mu from a systematic sample by using the sample mean y bar. This outcome is shown in equation 7.1. Estimator of population mean mu hat equal y bar systematic equal summation yi over n, where the subscript is y signifies or abbreviated for the systematic sampling was used. Estimated variance of y bar systematic v hat y bar systematic equal 1 minus n small over n capital multiplied by s square over n. This is a second important equation in chapter number 7, systematic sample 7.2. Assuming a randomly ordered population, randomly ordered population. you will recognize that the estimated variance of y bar systematic given equation 7.2 is identified to all estimated variance of y bar obtained by using simple random sampling section 4.3. This result does not imply that the true variance of y bar systematic is the same as that of y bar. The variance of y bar is given by v y bar equals sigma square over n small multiplied by 1 minus n small over n capital. This is equation 7.3. Similarly, the variance of y bar systematic is given by v y bar systematic equals sigma square over n multiplied by 1 plus n small minus 1 multiplied by v. This is a fourth important equation 7.4 in systematic sampling. Now, important definition 7.2. A population is random if the elements of population are in random order. A population is ordered if the elements of population have values that trend upward or downward when they are listed. Again, a population is ordered if the elements of population have values that trend upward or downward when they are listed. A population is periodic if the elements of a population have values that tend to cycle upward or and downward in a regular pattern when listed. A population is periodic if the elements of population have values that tend to cycle upward and downward at the same time or in the same time in a regular pattern when listed. This is the definition of population. Population is ordered, population is periodic. Again, a population is random if the elements of population are in a random order. A population is ordered if the elements of population have values that trend upward or downward when they are listed. A population is periodic if the elements of a population have values that tend to cycle at the same time upward and downward in a regular pattern when listed. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.